Alright, so what we're going to talk about in this tutorial is how to apply double angle identities. Now keep in mind that we can apply double angles with a problem like we're about to do here in just a minute, but also when we're solving trig equations or verifying trig identities. For this tutorial, we're just going to talk about this specific style of question, not equations, not verifying identities. So first things first, there are the double angle identities. One thing I want to mention, there are actually three versions of the double angle of cosine. I only put one up there, but there are two more, which I'm not going to get into right now. I guess real quick I could say that cosine squared can be rewritten using a Pythagorean identity, and sine squared can be rewritten using a Pythagorean identity, so that's why there's three different versions. Okay, so let's take a look at this example problem. It's asking us to find the double angle of sine, the double angle of cosine, and the double angle of tangent given that information. We know that sine is 5 over 13, and we know x is between pi over 2 and pi. So the first thing we want to figure out is which quadrant are we in based on this interval here. Okay, so hopefully we understand that based on that, I'm going to be in the second quadrant. Oh, that's a pretty bad line there. Let me redo that. So I'm going to draw myself a triangle in the second quadrant. Let's see if I can do, oh, that's not much better. All right, so here we go. Draw a triangle there. This is going to be x. Now, we know that sine is opposite over hypotenuse, so this will be 5, which makes this 13. That is a Pythagorean triple, so this is 12. And it's going to be negative because I'm in the second quadrant. So the first thing we're going to always try to do is draw a triangle based on the correct quadrant, and then we're going to just use SOHCAHTOA and Pythagorean theorem to find the missing either leg or hypotenuse. Okay, so now let's talk about the double angle of sine. So I know from the page before, the double angle of sine is equal to 2 times sine times cosine. So I'm going to write that out first. And I'm going to use my triangle that I just drew and just simply insert my ratio for sine and cosine. Now, one thing that I always like to do is I always like to put the 2 at the front. I like to put it over 1. So that all three pieces are fractions. My sine is 5 over 13, again, opposite over hypotenuse. And my cosine is negative 12 over 13, adjacent over hypotenuse. Now remember, when we are multiplying fractions, we multiply straight across. So 2 times 5 times negative 12 is negative 120. And 1 times 13 is 169. That's a 9 there. Okay, that's it. That's my double angle for sine. So again, I just start with the formula, and then I use the ratios from the triangle that I drew, insert those into the formula, clean it up. Okay, cosine is going to be the same deal, but obviously different formula. So cosine of 2x is equal to cosine squared minus sine squared. Now we have to be careful when we square this that we square both the numerator and denominator. So the cosine is negative 12 over 13. I want to put that in parentheses. Anytime you're squaring something, make sure it's in parentheses. Minus 5 over 13 squared. Now, one thing that I like about these is a lot of times people get intimidated by the fractions. The good news is on these problems, your denominators are always going to match up, so the fractions aren't that hard to work with. Now, remember, when you square a fraction, you have to square the top and the bottom, so I get 144 over 169 minus 25 over 169. So as I was just alluding to, my denominators match up, and that'll make the subtraction pretty easy to manage. So 144 minus 25 is 119 over 169. So there we go. That's my double angle of cosine. Now, for tangent, I like to use a shortcut. Let me go back to the previous slide. There is this, this double angle identity right here, and that one is fine. Obviously, it works. But since I've already done my double angle of sine and my double angle of cosine, I prefer to use that. So that's the one I'm going to use here. So I'm going to do that right off to the right-hand side. I'm going to do double angle of tangent is equal to double angle of sine. Now, if you're wondering why, just think back. Remember that tangent is always sine over cosine. So the fact that I have a 2x there, that's okay. I'm still dividing sine and cosine. Okay, so my double angle of sine was negative 120 over 169. I always like to do a big fraction bar when I do this, just to make it a little more obvious where I'm separating the top from the bottom. And then the cosine was 119 over 169. Now what you notice, sorry about that bell, what you notice is the denominators match. And that'll always be the case, and they're going to cancel out. So I end up with negative 120 over 119. So again, we tend to be intimidated by fractions, but when we're doing these double angles, the denominators work out nicely, so they really don't pose a problem for us. We don't have to worry about common denominators because they're already going to be common. We don't have to worry about multiplying by the reciprocal for the tangent because the denominators are already going to cancel out. So that's it. So again, we figure out which quadrant to draw the triangle, and then we go ahead and draw the triangle and use Pythagorean theorem to find the missing leg or hypotenuse, and then we apply the three formulas. Be careful drawing the triangle, because if your missing leg or hypotenuse is wrong, then obviously it's going to make all three ratios wrong. So take time to get it set up before you just jump right into the formula. All right, hope that helps. Good luck on these.